in this question, we are supposed to use the Moivre's theorem to show this particular expression that we have here. If you are taking further pure math, this is the question that will be asked in further pure math 2. Further pure math 2, whereby you are told cos6 theta is equal to 32 cos power 6 theta minus 48 cos power 4 theta plus 18 cos squared minus 1. How do you use the Moivre's theorem in order to do this? So the theta plus I sine theta, you raise this to power n. What will it give you? This one is going to give you cos n theta plus I sine n theta. So similarly, this equation that we are having here, we can be able to use power 6. We're going to use power 6 in order to show that this. So I can be able to start by writing this right hand side, and I will say this can be written as let me just look for more space here. This can be written as cos 6 theta plus I sine 6 theta is equals to what? Is equals to the cosine of theta plus I, the sine of theta, raised to power 6. So which means this expression that I'm having here on the right hand side, I can be able to apply binomial expansion on it. So we can say apply binomial expansion at the right hand side. That is exactly what we are going to do in this case. So in order to expand this, we are going to say this is going to be cos 6 theta, cos power 6 theta, plus the second term will be 6 combination what? 6 combination what? It will be 6 combination 1 cos power 5 theta times I sine theta. That is the second term. The third term is going to be 6 cos 2, 6 combination 2 cos 4 theta times I sine theta raised to power 2. So you realize that whenever you are applying binomial expansion, the power of this decreases as the power of this increases. So we shall have the fourth term being 6 combination 3 cos power 3 theta times into bracket I sine theta power 3. After this, we have the next term plus 6 combination 4, 6 combination 4, and that become cos square theta times I sine theta raised to power 4. We have plus 6 combination 5, and that will be cos theta into I sine theta power 5, and then the last term is going to be I sine theta raised to power 6. This is the expansion that now we need to simplify in order to have our expression. So this becomes, of course, cos power 6 theta. This one becomes plus 6 combination 1 is basically 6 times I to be 6I cos 5 sine theta. Next term here will be plus, what is 6 combination 3, 6 combination 2, 6 combine, we need to be very sure about it. 6 combination 2, that will give us 15. Yes, this I is squared, right? So when I squared, it becomes -1. When I squared, it becomes -1. So we shall have this term -15 cos power 4 theta sine squared theta. Then this term will be what? 6 combination 3. that will give us 20. So it will be 20, but it will be still we have I cubed. What's I cubed? I times I times I, it will be negative 1I. So we shall have here negative 20I cos cubed theta sine cubed theta as well. Then we also have this term here. We shall have positive because I is going to be raised to power 4, so it will be positive. What is 6 combination 4? That's going to be 15. So we shall have 15 cos square theta sine power 4 theta. Next term for this one, it will be plus 6 combination 5 is going to translate to 6. Yeah, that will be 6I cos theta sine power what? Power 5 theta. And lastly, it will be minus 6 minus sine power 6 theta. So basically what we're going to do next, the next thing that we're going to do, because we were supposed to show this expression, you see we are having cos 6 theta is equals that. We don't have any imaginary part. Because this expansion that we have is basically the cosine of 6 theta plus I sine 6 theta. You see it's having a mixture of complex numbers and real numbers, imaginary numbers and real numbers. So what we're going to do, we are going to equate only the real part. So we can say here equate the real part. So equating the real part, so meaning we're going to take this and say our expression is going to become cos 6 theta is going to be, what is the real part in this? We have the real part here, we have the real part here, we have the real part here, and we have lastly the real part here. So those are the only part that we're going to equate, and in that case we're going to have cos power 6 theta minus 15 cos power 4 theta sine square theta. Then we have plus 15 cos square theta sine power 4 theta, and lastly we shall have minus sine power 6 theta. Now we are almost home and dry. Something that we need to realize in this equation that we were supposed to show, we don't have a sign there, so we're going to replace anywhere we have sign, we're going to replace it with something else. So you remember the Pythagorean identities that says cos square theta plus sine square theta is basically 1. I believe you remember that. And then from this we can say sine square theta is equals to 1 minus cos squared theta. So anywhere you have sine, you can be able to replace it with this part that we have here. Okay, so basically that's what we're going to do in that section. So we need to start that process, and we're going to say this is going to be equals to cos power 6 theta minus 15 cos power 4 theta into 1 minus cos squared theta, then plus 15 cos squared theta into 1 minus cos squared theta cos squared theta raised to power 2, because this is actually raised to power 4. So I would have taken, I can be able to say this can be written as sine squared theta raised to power 2. So that's why you can see I'm doing this part at this point. So that's it. And then I have here what? this one I can be able to write it as sine power 2 theta raised to power 3. So meaning this one I can be able to say minus 1 minus cos squared theta raised to power 3 at that point. So the only challenge I have at this point of time is to ensure that I'm able to expand these guys so that I can be able to get what I'm supposed to substitute at this point. So I can say my equation here, which is cos power 6 theta, I can expand here. I'll have minus 15 cos power 4 theta. Help me work it together here. So this is going to be plus 15 cos power 6 theta, because power 4 times power 2 will give me power 6. Power 4 times power 2 will give me power 6. Power 4 times power 2 will give me power 6. And then I'm done with this. The only challenge I have here, this expression that we have at this point, this one that we have here, what can it be replaced with when you expand? This part that we have here can be replaced with 1 minus 2 cos squared theta plus cos power 4 theta. If you expand this, you will get this. So which means that we can be able to say 15 plus times 15 cos squared theta times 1 will be 15 cos squared theta. Are we together at that point? Yes. So again, 15 times minus 2 will be minus 30 cos power 4 theta. Because this is power 2, multiplying with power 2 will be power 4. Yeah, let me write it properly. 15 cos squared theta times negative 2 cos squared theta will be negative 30 cos power 4 theta. 15 times this, it will be plus 15 cos power 6 theta. This is power 2, this is power 4. Are we together? So I also have a challenge of what will this expand to? What is this going to be expanded to? So I have to consider also that. But I know I don't want to really need more space on that. Something I know is that this that I'm having here can be written as this one here can be written as 1 minus cos squared theta raised to power 2, again 1 minus cos squared theta. It can be written that way. Yes, but this part is 1 minus, so let me start by writing this 1 minus cos squared theta. This one now becomes, or already we have it here, 1 minus 2 cos squared theta plus cos power 4 theta, right? Are we together? All right. Then if I multiply here, I'll be having 1 minus 2 cos squared theta plus 1 times this, 1 times this, and 1 times that. It will be cos power 4 theta. This times this will be minus cos squared theta. This times this, it will be plus 2 cos what? Power 4 theta. This times this will be minus cos power 6 theta. I believe that's okay. So we can say, can we add this and put the like terms together? Yeah. So this is going to be cos squared, so it will be 1 minus 3 cos squared theta. I'm done with this one and this one. So I'll talk to these guys. What are they going to give us? They will give us 3 cos power 4 theta. Yes. And then finally we are done with them. And then we shall have yes, we are done. Then we're going to say cos power 6 theta. So meaning this part that we are having here, this one here, is replaced with whatever we have gotten here. So I can be able to write that and say that this is going to be minus, the first term is 1, so it will be minus 1. Is this space going to be enough? Okay, so minus times this, it will be plus 3 cos square theta. Just looking to see whether I'm writing so that you can see, because I may end up writing to the rest of the board and you end up not seeing what I'm writing on, but you'll be hearing me talking. Yes, just relax a little bit. Yeah, so okay, let's proceed. This will be minus 3 cos power 4 theta, 3 cos power 4 theta. Are you able to see? Let me write it properly. Minus 3 cos power 4 theta. Yes, then finally, almost enough, I'm going to write in that plus, it will be plus cos 6 theta. I believe you can see that. Now we need to put the like terms together. Right, let's do it now. We are almost. So this is going to be what? I want you to check with me where we have cos power 6, power 6, power 6, and power 6. This is 1 plus 15 plus 15, that becomes 31 plus 1. That gives us what? 32. Good. We have 32 cos power 6 theta. Next term is power 4. Power 4, I want to use a different pen. Power 4 will be power 4, power 4, power 4. Is that all? Check with me. 15, that gives us negative what? Negative 45. That becomes negative 48. Yes, so this becomes negative 48 cos power 4 theta. Then we need the one that is having power 2. We have power 2. We have power 2 here. Any term with power 2, let's look for it. Any term with power 2. Power 2. 15 plus 3 will give us 18. So we are going to say this is going to be plus 18 cos power 2 theta. Then we have the next term that is remaining, which is minus 1, and we have used the Moivre's theorem in order to show this. That's basically what you do in order to show using the Moivre's theorem. See you in the next video. And by the way, if you have not subscribed, consider subscribing so that when I'm going to upload a video like this on Further Pure Math, you'll be notified. See you in the next series.